To draw the derivative function, let's start with the very obvious. Where is the slope 0?
Over there.
Right here and right here, right? So that's where we're going to start with first. I know that the derivative function will be 0 there and 0 at that x value. Is that fair? How do you know for sure the slope is 0? What is this slope here? Like if I drew a tangent right there. What's that? That's a positive slope, right?
Yeah.
Positive, right? Positive, right?
Yeah.
How can no? What about here though?
Negative.
Is it possible for positive to become negative without becoming 0 first?
그럼 모든 곡선이 다 그런데요.
So every time it goes up and down like this, it has to be 0 at some point, and then at the very tip.
아까 여기라며.
So we can be 100% confident that that right there will be 0, and that like right there will be 0. Okay. The rest is a little bit of an approximation. So look, we have slope here, and it's pretty flat, but maybe it's a little bit tilted up, right? So that means it's gonna be a little bit above the x-axis, like this, and it's increasing, right? Right? The slope's getting more steeper. Do you see? Like here, it's getting more steeper, really steep, right? But then at this around somewhere around here, right, somewhere around there, around here, it starts to decrease in steepness. Okay, so that means you gotta increase your graph up to a certain value. So this, it's an approximation. Like this slope could be like 100, it could be 20, right? Totally depending on interpretation, right? Unless I give you, exactly what this function is. So it's gonna go up to a particular value, okay? And then, sorry, it's gonna go up, and then from there it's gonna come down. Right, so how high it goes up is totally dependent on how high the slope value is. Okay, so it's gonna go up. We just know that around there, it's gonna go up to that point, and it's gonna have to start coming back down. Now the slope after this 0 slope continues to be negative, right? Continues to be negative all the way to here, right? Right. But again, look, it's really negative. It's really negative, but then it starts to become less negative. Look, right? That would be like negative 4. This would be like negative 0.4 or something like that. So it's gonna go down, right, to a maximum negative slope, and it's gonna come back up. And after here, the slope is positive again, right? It's gonna increase like that. Okay, so these points where the slope is going down, but then somewhere here, like it becomes more positive, right? These points also have a name, but we're going to discuss more about them later. It's called inflection points. Right, these are called, we've seen this in advanced function, local max and local minimum. Okay, local max and local minimum, the derivative function will be intersecting the x-axis. Okay, so this is what approximately, the red graph is approximately the picture of the blue function. Okay, red is approximately the derivative function of the blue.